Hello everyone, welcome to Cyber Platter, and this is our full course on the CCSP exam. It covers all the topics that are required to pass the CCSP exam and to enhance your cloud knowledge. At the end of every video, we have added important pointers that are very much required for this exam. Please make sure you go through them. So CCSP exam is from ISC Square. ISC Square provides you an exam outline. This should be the first step in preparing for your CCSP exam, right? And you should know all the concepts that are covered in here. I have added the link to this in our description, and you can also Google it saying ISC Square CCSP exam outline. So if you scroll down, it actually tells you that this is a 3-hour exam and it has 125 questions and 70% is the passing score. If you see here, today we will be covering a chunk of topics from Domain 1. Domain 1 has 17% weightage in the exam. So if you scroll down here, right, it has many partitions. So in Domain 1, Architecture and Design, it has 1.1, 1.2. The ultimate goal of this course is to cover every point. That is 1.1 in this video will be covering. In the other videos, we'll be covering 1.2, 1.3, and we'll complete all the topics that are mentioned here so that you know everything that is required for the examination, right? Let me go back to the slides. So here in this episode, we will cover 1.1 of Domain 1, that is the cloud computing concepts. We will talk about the definition, the roles that you need to know, the key characteristics, and the building blocks. So the only topics I have not mentioned in the slides are about networking and databases that are in the building block technologies, because it is very similar to the traditional storage and databases and networking. And from the cloud perspective, we will cover it when we talk about networking security and database security in the other videos. So it will be covered. Don't worry about it right now. So the first concept is cloud definition. NIST SP 800-145 provides a cloud definition. If you see here, it has a lot of words like ubiquitous, convenient, on demand, right? For now, just understand that cloud computing is a delivery model for the services. Services can be anything as it is mentioned in this image here, but not just limited to these. Suppose say you need to store data in cloud. Cloud providers provide you services for this, like files and databases. When I say storage, it is just not the files and the databases. It is also the tools that are required to migrate the data from on-premises to the cloud. Once you have the data in cloud, you need computing power to process the data, right? So you have computing power, that is the VMs, containers, serverless computing. Okay, once you have this computing power set up, now all of this should be connected in a secure manner. That is when the networking part comes into play. So once you have all of this like networking, storage, computing power setup, then you have to have business intelligence for analytics. You need security for it. Cloud computing is available everywhere, that is on mobile phones as well. It provides all the services. So all the services delivered over the internet that are provided by the cloud service provider is cloud computing. We will learn about the terms ubiquitous, how it is made available to everyone and how it is made available everywhere, and how come it is so convenient, how on demand whenever you require it, you need it, you can create the resources. We will talk about how the resources are shared and how quickly we can provision the resources with minimal interaction with the service provider. all in the future slides. So this definition will make complete sense to you once you know about the key characteristic, roles, and the building blocks of cloud computing. So let's go to the next page. We will talk about cloud computing roles here. ISO IEC 17789 specifies the cloud computing reference architecture. Try to remember that ISO 17789 is related to cloud reference architecture, and this reference architecture includes computing roles, computing activities, cloud computing functional components, and their relationships. Okay. The first one here is cloud service provider. It is the company that provides you the cloud services. For example, Amazon, Microsoft, Google. Next one is cloud service customer. It is the company or the individual who consumes the cloud services that are provided by the cloud service provider. When I say consume, it can be like they can purchase it or rent it or lease it, right? The next one is cloud service user. Cloud service user is the individual who uses the services provided by the service provider. Suppose say there is an organization. The organization is the consumer. The employees in the organization are the users. The next one is cloud service broker. So as the name specifies, a broker is somebody like a third party company which purchases the services from the cloud provider and resells it to its own customers. Remember that cloud service provider provides cloud service broker provides intermediation, aggregation, and arbitrage services. Okay. The next one is cloud carrier. Cloud carrier is an intermediary company which provides the connectivity and transport of the services between the provider and the customer. Remember that cloud carrier example is ISP. The next one is cloud service partner. Cloud service partner is someone who supports the provider and the customer in provisioning, in the usage or other activities that can be done in cloud. Let's go to the next slide. The next one is CASB, Cloud Access Security Broker. This is important, so remember about CASB, right? CASB is a third-party company which provides identity and access management services to the providers and to the customers. It can help you with single sign-on, cryptographic key escrow, certificate management, monitoring. The next one is Cloud Service Operations Manager. It is an individual who manages the operation and performance of the cloud services. Next one is Cloud Service Technical Account Manager. This is someone who provides account support and high-level technical guidance to cloud customers. Cloud Service Integrator, as the name suggests, it is an individual who connects and integrates existing services and apps with cloud-based services, right? The next one is Cloud Service Admin. Cloud Service Admin is responsible for testing, monitoring, securing cloud services. He also provides the usage reports. If there is any problem with cloud services, he also deals with it. Right? Most of these are familiar with the traditional roles and responsibilities, like the admin and traditional data center as well is responsible for almost the same things, right? Like testing, monitoring, and securing your services. Operations manager is supposed to manage the operation and the performance. So once you start reading about CCSP and you go through the other domains, these terms become more familiar to you. The next one. Okay. The next topic is key characteristics of cloud computing. So let's start with broad network access. Broad network access, what does that mean? So when we read the cloud definition from NIST SP 800-145, right? We saw a term called as ubiquitous. That means it is accessible from any device and from any location. That is what broad network access is, and all the services are accessible over the internet. What are some of the concerns when we talk about broad network access is that whenever you talk about over the internet, bring your own devices matter here, right? Because users can use their own devices. That is one of the qualities of cloud as well, to make accessing the resources easy. Here, the security concern is how do we manage bring your own devices, right? How do we provide secure access to the services? So those things need to be considered. Okay, the next one is resource pooling. Resource pooling is one of the fundamentals of cloud computing. Resource pooling actually allows the cloud service provider to meet various demands from the customers and also make it financially viable for the cloud providers, right? Resource pooling makes sure that the resources are not underutilized or overutilized. So if it is underutilized, then you're wasting the resources. That it is like a wasteful investment. If you are overutilizing it, then you are decreasing the level of service. So resource pooling stacks up the resources and then apportions these resources as needed. Whenever who wants it, it gives it to them. Because of this, there is no overutilization or underutilization. It is noteworthy to mention multi-tenancy here. Multi-tenancy builds upon the concept of resource pooling. So the resources are shared between multiple tenants, like the customers. So when you're considering multi-tenancy, take for example, there is a physical server. On top of this physical server, you are building many virtual machines. Virtual machine 1 may belong to organization 1 and the second virtual machine may belong to organization 2. Both of these virtual machines, though they belong to different organizations, will be utilizing the same resources of the same physical server. Right, so we have to make sure that there is very strict isolation between the virtual machines so that no data is accessible from other tenants, right? Who other tenants in the sense, I mean the ones who are sharing the resources. In traditional data centers, we wouldn't have come across this because we have only our organization consuming all the resources, right? So there are many technologies like encryption, which plays a very major role in cloud computing to enforce isolation. When considering multi-tenancy, there are legal risks as well. Suppose, say, there is intellectual property, right? The question arises, who owns the data in the cloud, right? There are also restrictions on highly sensitive data being hosted on multi-tenancy architecture. We will go through this in other slides. So just understand that when it comes to multi-tenancy, make sure that there is strict isolation that is provided, and there are few legal issues that are attached to multi-tenancy. Yeah. Now let's talk about on-demand services. On-demand services is the model where the customers can create their own compute and storage resources without any interaction with the cloud service provider, right? And this happens in real time and it saves a lot of time. Just imagine that we needed a server in traditional data center. We have to apply for, apply in the sense request for the server, then it has to get approved, then the server needs to be built, and then it has to be delivered to you. It's a long process and it can take a couple of weeks or even months, right? But here it is just a matter of few clicks and the server is provisioned for you. The next one is measured services. So measured service, this is where it allows you to save a lot of money. Like the customer is charged only for what they use and nothing more than that. It's pay as you go and you're paying only for what you use. The next one is rapid elasticity. Rapid elasticity. To understand rapid elasticity, first we will talk about scaling. So suppose, say you have a resource. It can be anything, right? A storage space, a server, or an application. For here, we'll consider a server. Suppose the demand increases and you want to increase the size of the server, that you are increasing the server power like increasing the CPU, memory, and storage. This is called as vertical scaling because you're increasing the size. It is called vertical scaling. When you increase the size, it is called scaling up. When you decrease the size, it is called as scaling down. There is something called as horizontal scaling as well. If the amount of servers is increased, suppose in the application you have one server and you add a similar additional server or two more servers or three more servers, it is called horizontal scaling. If you are adding resources, that is increasing the amount of resources, it is called scaling out. If you're decreasing the amount of resources, then it is called scaling in. Now we will talk about rapid elasticity. Now that you understand what scaling is, if this process of scaling is automated, then it is called as rapid elasticity. How fast you can provision, you can add the resources or remove the resources, increase the size or decrease the size based on the demand is rapid elasticity, right? Imagine that there is an application which requires a lot of resources during the holiday season, but if it is not holiday seasons, not so much, right? Automatically, the application understands that the resources are required and it starts adding up the resources. And once the holiday period is done, when the demand goes down, the resources will be decommissioned. Okay. Here you should also be concerned about the abuse of cloud services. Suppose, say there is a DDoS attack on your application. It's the servers keep on multiplying and it adds up to your device as well. So you have to be a little careful. Okay, the next topic is virtualization. What is virtualization? Why should I even consider virtualization, right? Virtualization is one of the fundamental blocks of cloud computing. We will understand why we need virtualization here. Suppose, say, in the traditional data center, how we were using the servers. You have the hardware, that is the physical component. On top of that, you have the operating system, and the operating system has its own services, file storage, ports, input, output. On this, we have many applications that are built. Every application is dependent on the same file storage services, ports, and I/O. So what happens in virtualization? You have physical server, that is the hardware. On top of that, you have operating system. But additional to that, you have a virtualization software, hypervisor, sitting on top of the operating system. Top of the physical server, we have virtual machines, and this virtual machine has its own services, file storage, ports, IOs, and it is dedicated to one application. So this application has its own specifications, right? Like this, you can build multiple virtual machines on this hypervisor now. Hypervisor should make sure that there is isolation, and app 1 should not be able to see what is happening in app 2, or it should not get to know what kind of resources are utilized by it. There are few points that I wanted to mention about virtualization, which might be important to the examination. Virtualization is emulation of physical machines, right? And is the basis of multi-tenancy, resource pooling, and scalability, which we talked about in the previous slide. So the problem with virtualization, suppose say there is a virtual machine which is switched off for a long time, right? It has a problem of missing all the patches. That is called as instant on grab. Means when you switch on a server which has been turned off for a long time, it is very vulnerable because it has missed a lot of patches and updates, and it is not currently very secure. Another problem with virtualization is powered up virtual machines are still susceptible to malware infections, because when it is turned off, a virtual machine, it is stored as a virtual image, and these virtual images are nothing but files. So it is still susceptible to malware infection. There is one more concept that you would want to know, that is virtual machine introspection. Virtual machine introspection is the one which allows you to get the details about the guest OS, right? Like, for example, what are the processes running on it, what are the active network connections, what are the files that are open. This is widely used. VMI is very much in use for malware analysis, for forensics related to memory and process monitoring. Okay, the next one. The next topic is hypervisor. Hypervisor is the virtualization software. Hypervisor is the one that enforces isolation in virtualized environment, right? There are two types of hypervisors, type 1 and type 2. Type 1 hypervisor is installed directly on the hardware, and type 2 is installed on the host OS. Type 1 hypervisor is considered to be more secure than type 2 hypervisor, because type 2 hypervisor has more attack surface because of the extra host OS layer. Hypervisor collects the data about the guest operating machines through VMI, which we talked about in the previous slide, virtual machine introspection. Okay, the next topic is object and volume storage. These are very commonly used storage types in infrastructure as a service, which will be infrastructure as a service, platform as a service, software as a service. These are the service types provided in cloud, which will be discussed in the other videos. For now, just remember that object and volume storages are very commonly used in infrastructure as a service. The first one is object storage. Object storage is less expensive because you pay for only what you use. Okay, this has unique address identifier and metadata attached to it, which helps in better indexing, which indeed helps in better policy enforcement, data policy enforcement. This is very helpful in data loss prevention and information rights management, which are two different topics and will be discussed in other videos. The object storage is a flat file system which is accessible via APIs or web interface. So one more thing that you have to remember is that you cannot install or run programs on object storage. The usage is limited to uploading, storing, and editing the files. Virtual images, that is when the virtual machines are switched off, virtual images or snapshots are usually stored in object storage. The next one is volume storage. Volume storage is nothing but virtual drives. It is attached to the virtual machines. There are two types of volume storage, that is block storage and file storage. Here you can also run and install programs other than uploading, storing, and editing the files. Block storage uses iSCSI protocol. Just remember that. I thought maybe it will be important for the exam, so I mentioned it here. Whenever you allocate a volume storage to a host, it is called as logical unit. One more point that I wanted to mention here is object storage is usually used for huge files, okay, like media files. Let's go to the next slide. Yeah, like I mentioned before, we will talk about infrastructure, platform, and software as a service in the other slides. For now, remember, this is important for the exam that you remember what type of storage is used. Object and volume is used in infrastructure as a service, structured and unstructured. Structured, for example, relational databases. Unstructured is image files, video files, text files, everything is for platform as a service. In software as a service, you have two types again, that is content and file storage, which the data that is within the application, and the other one is which is entered into the system via web UI, that is information storage and management. Okay, the next one is orchestration. Orchestration is the core component of cloud computing, right? It is automated cloud management. There are many operational tasks, say for example, infrastructure deployment, code deployment, logging, monitoring, all these can be automated. The governance activities as well, like dashboarding, reporting, security policy deployment, all this can be automated. Orchestration builds upon the concept of infrastructure as code, that is IAC. IAC is used to manage and provision infrastructure through code instead of doing it manually, right? There are many benefits of orchestration. A few of them I have mentioned here. For example, it reduces errors because it provides a standardized template, right? And you're deploying the same code everywhere, the errors are reduced. It also increases the speed because it is automated, obviously. There is cost reduction, there is consistency because of the standardization, and you can enforce the baseline. To enforce the baseline, it is an easier way, and you can eliminate the configuration drift. Okay, the last slide for this video is about the important pointers, as I mentioned initially, that we wanted to cover, which is important for the exam. The first one is that always remember that the cloud customer is finally responsible for the data and the security of the data, even though the fault is from the provider's side, right? For any data breach, still the customer will be legally responsible for the data and its security. The second one is what are the building blocks of cloud computing? That is CPU, RAM, storage, and networking are the building blocks of cloud computing. The next one is always remember that security is not free. It comes with a cost. It costs money and it reduces the performance, like the functionality, quality of service. The more secure an application is, it's probable that the performance or the functionality has reduced. The next one is capital expenditure is shifted to operational expenditure in cloud. The initial cost of setting up so many servers, storage spaces, or the data center will not be there in cloud. So the initial cost is very much reduced, that is the capex. Security decisions are always driven by the organization's business needs. It is not the other way around. Business needs are the primary factors to decide the security. Automation helps in continuous monitoring and reporting in cloud. Monitoring includes security monitoring as well. Cyclic application. What are cyclic applications? We talked about it before when we were talking about rapid elasticity, like for the applications which have demands in only certain period of time, like holiday seasons. For example, some of the retail companies will have demand only during the Thanksgiving or Christmas, right? And for the other period of times, it might not have so much demand. Those applications are called as cyclic applications. Those applications are very much suited for cloud, best suited for cloud actually. And orchestration and virtualization from cloud. So if you want more information about what happened in this video, please go check out our Discord server, and we also have uploaded few of the items on our website cyberplatter.com. Please check it out. If you liked what you heard today, or if you learn anything from today's video, please like, share, and subscribe. Thank you so much, guys.